one of the earliest explosives is gunpowder. And the recipe for gunpowder is charcoal, potassium nitrate, which they used to call saltpeter, and sulfur. And explosives are made by just combining some source of combustible fuel with an oxidizing source. And it's a lot easier to not just have oxygen in the air be the oxidizing source. That's why things like nitrates make great oxidizing agents. So to have it mixed in right there makes for a more spectacular explosion. Nowadays, modern explosives have the oxidizing agent chemically bonded to the molecule that's going to react. That's how nitroglycerin came about. That's how trinitrotoluene, TNT, came about. But in the old days, you didn't do that. You just sort of mixed them together, and they were close enough in that way. But what predates gunpowder, as far as they know, is something that they called the elixir of life, which is where instead of charcoal, they actually used some type of honey. Probably not the Whole Foods brand, but some type of honey, and that replaces the carbon. And because honey is a syrup, it has moisture in it, and that starts to dissolve potassium nitrate and get everything much more particulate and closer together in the mixture. So I actually need an assistant to come help me measure things out. How about a gun?
Cheat.
Throw that aside. Okay. All right. So what I need you to do is we've got plenty of scoops and things like here. I'll do the sulfur. And you just give me that one scoop, that potassium nitrate, and put it in our little bowl. And it's about equal portions of potassium nitrate, and I'll do the sulfur. And I'm going to let you eyeball about another scoop or so of the honey, maybe a little bit more. You can use the scoop or just approximate it. Yeah. This is no alchemy, so we're not using balances or scales. I would say a little more than that. Yeah, okay, that's good. Now you got a stirring rod there. So just try and mix those up, and you should make a nice little paste. Okay, that's good.
Niels.
Yeah. All right. So now we're going to take this over to the hood in the lab, and we're just going to cook it. And that's going to heat off all the moisture, and then eventually the temperature will be high enough. I think we'll hit the activation energy for this reaction, and it will just go up. And that's what we're going to try and catch. Take some time.
What exactly is the reaction?
You need to look that up. But it is mostly the combustion of carbon in the honey.
Yeah, it looks like glue.
Okay. All right, so you can carry that over. You know, it might make a sound, but you'll know it just goes off all at once. It's getting there.
Oh my god. And there goes another
And I didn't want to clean that dish anyway. So. And we turn off the heat, just in case. So you can see why I didn't want to scale this up to the size that you wanted to do originally.
Oh wait, so the bubbles are blue.
Yeah.
We're gonna waste
And
a
a
lot of
better
money.
thing to do would be like a metallic container, but I just couldn't find one that was the right size. So I have these tiny.
Oh,
little
you see, do you see the blue?
I do.
The blue?
Just a little
Flame.
Oh, there should have been like a violet flame, right, from the potassium?
Yeah, there's a purple
definitely.
flame. There's a purple flame.
Definitely, yeah. Ta-da!
Fun one.
That's it. Yay!